Welcome back to the Introduction to Kismet. In this video, we are going to add on to our existing sequence so that our light switch resets after a few seconds, counting down from 5 to 0 yet again, and then turning the lights back on.
Yeah, this is the whole restarting the system thing.
That's right. So let's pop and take a look at
Let's go and maximize that.
All right. So let's make it nice and big so everybody can see. So here's what we have so far. We run the whole sequence, we do our countdown, and then we toggle the light off in this case because it begins by being on.
That's right.
As soon as the light goes off, I want to wait a couple of seconds and then send a message out to the user saying that the system is restarting. Now, we've already got the log in place that we need to do that. Let's just make a copy of it.
Okay.
We'll hit Control-C, we'll fly over here, hit Control-V, and then we'll just disconnect the node, and we'll recycle in that way so it's a little faster. So I'll connect this in. Let's change the value of this from you have activated the timed light switch to, let's see, system...
Restarting in,
and then we'll do a little ellipse.
Okay.
Because then we're going to refire out those same numbers back out to the screen. Now, to make things a little easier, or maybe just a little more natural, we're going to delay that a little bit. So let's right-click, and we'll do Set Activate Delay to about 3 seconds. So we'll spend 3 seconds in the dark, and then we'll get our little system restarting message popping in. If you want, we could go ahead and test that real quick.
Okay, so there we go.
5, 4, 3, 2, 1, boom, and there we go. Now here's the thing:
there we go.
System restarting in. There we go. So we wait 3 seconds, and everything comes in, but we don't have a countdown, and the lights aren't coming back on.
That's right.
So that's the next thing we need to add in. So what we're going to do is just start off simply, and this is just to kind of show you what we're up against. I'm going to take my log, and we're going to plug it back into this log over here, because that's where our loop begins, right?
So if you think about it, we've already got problems by doing this.
But let's show what the problem is.
Sure.
So we walk over here, and we count down. We get 5, 4, 3, 2, 1, and then the lights go out. We wait our 3 seconds like we're supposed to. Yeah, system restarting in, -1.
And stop because, of course,
And then, nothing because...
less than.
The loop isn't going to work at that point. So what we need to do is reinitialize our counter back to a value of 5.
That's right.
We did that over here with our initialized counter that we created earlier. So let's go ahead and hit Control-C, fly over here and hit Control-V. We'll disconnect it from there, but we'll leave it connected back over to the variable just because it's easier that way. Let's disconnect this wire, and we'll plug these two guys together. I guess we'll go ahead and leave that delay in there. It'll just make it seem more natural again.
Yeah, it'll feel exactly like the first one.
Exactly. Now we need to turn this into a loop, so we'll take our output all the way back over here to our initial log.
But Zach, even this has a problem.
Sure.
Let's show it to him.
All right. So let's go ahead and walk over, play from here, and bing.
It is indeed going to work much better now.
This is my favorite problem.
Have you guys been able to identify the problem yet?
Boom, 0.
Okay, yeah, that worked good. 3 seconds.
System restarting in.
1.3, here we go.
2, 1.
And it works.
Boom, system reset.
All right, but there's more.
But if you sit here, another system restarting message comes up, and it will continue to do this indefinitely. We will sit here and have the lights automatically turned on and turned off infinitely for the rest of the time we're playing the game. What we need to do is put a little check system in place that checks and sees if we really need to restart the system.
That's right.
And to only restart it if the system deems that it needs to be done.
Now, put on your logic thinking caps. You need to keep this next part clear in your head.
Yeah, because this could get a little confusing if you're not used to logical thinking. How do you do a check and see if something actually needs to be done? You need to have some sort of a criteria. You need to have something that says, yes, we are ready to reset. In this case, that means the lights are off. So if the lights are off, we need to restart. If the lights are on, we don't need to. Now, there are a lot of ways we could approach this. We could create a Boolean value that we create a node that automatically sets that Boolean value, and then another node that checks that Boolean value, and all sorts of stuff. Fortunately, we don't have to do that. The toggle already has a Boolean input. This Boolean will be toggled at the same time as the light. So what I'm going to do is just right-click here on our Boolean input, create a new Boolean variable, which by default is set to false.
And that's very important here.
Let's go ahead and break this connection between our toggle and our log, and I'll create a new condition, which will be a bool comparison, or a Boolean comparison. We'll plug our output to the input here, and we'll take this Boolean value and we'll plug it in here. And what is this actually doing? This is checking to see if our light has been toggled off. This is a lot like saying, let me change the object comment. We'll set this to, do we need to reset? The first time you run through, no, you don't need to reset.
That's right, but we just took our light and we turned it off. And when we turned it off, what do we do with our false? We toggled it to true. So the next time we come back through, it's going to be true. Yes, we need to reset.
That's right. Or another way to put it would be, are the lights on? And that's going to say, the first time it comes through, it's going to say false.
Mm-hmm.
Because, well, actually, it's going to say...
the lights are actually going to get toggled off, and that's going to get flipped to true.
Right, so you want to say, are the lights on? Or are the lights off? So there's where logic comes into play.
Your first question was actually really good that you had up there.
Right.
But this comes in, and it's starting off at false. All right, let me grab a mouse right here.
Let me put this back the way it was. So this will be, do we need to reset? Because I like that better.
Yes, so do I. Okay, so we start out. This guy's false right now, right? But the lights are on. So the first time we come in here and turn the lights off, this comes through into the toggle. Lights get turned off, and this gets toggled to true, okay?
Now we do need to reset.
So now we need to reset. So then we're going to output this.
We make sure we output the true over into our log.
That's right.
Now the next time we run through, we run our little loop. We toggle again. Suddenly this is set back to false.
That's
and
right.
our compare bool says, do we need to reset? Well, currently this is set to false, so do nothing.
That's right. So we drop out.
That breaks us out of that infinite loop. So let's go ahead and try this one more time. And boom, here we go. 5, 4, 3, 2, 1, boom, 0. Wait a second. System restarting in 5, 4, 3, 2, 1, boom, and there we go. And now if we wait for 3 seconds just to make sure, you'll notice that nothing else happens.
And everything is good to go.
Everything is good to go, and in fact, we could fire it off again if we wanted to, but we are essentially done with everything I wanted to demonstrate in this video. We only have one little problem left, and that is that a user can step all over this. They could walk in at any moment, like right now, and hit E again, and you've activated the timed light switch. 5, 4, 3, 2. Well, we've activated it again. And so it just, we're kind of breaking the system.
Yeah, so in the next video, we're going to fix this problem and make it foolproof.
That's right. So that's going to wrap things up for this video. Thanks a lot.